Hi guys. So yesterday I did a presentation with Xander from the podcast called Beyond the 20 Rules, and in it we did an item review. We talked about item formulation. We talked about 20 Rules of Knowledge Formulation by Piotr, and we also added some of our own extensions. And right at the end of that presentation, we talked about something that I'm super interested in, which is knowledge valuation. You know, what things are actually worth encoding as items. And so that's basically going to be the topic of this session. I'm going to be doing some research into sort of valuation in general, and then focusing on knowledge valuation specifically. And I think that SM is very, very well suited to this sort of highly interdisciplinary inquiry, essentially. You know, with valuation, there's so much to talk about. You can talk about stocks, money, knowledge, of course. Talk about hoarding, real estate, yachts, and of course, we can also talk about antiques. And so before I get into the research, I kind of wanted to show you a clip from one of my favorite TV shows at the moment, which is called Bargain Hunt. And in Bargain Hunt, you have two teams. They have to go to a garage sale. They have to buy 3 items and sell them for the most profit at auction. And this is one of the most interesting items I've seen get sold at auction on this show. And I wanted to show you it to sort of, prompt some ideas about, why people value certain objects. What are the properties of these objects that they value? And is there some sort of underlying framework guiding, their decision to value something highly or not value it very highly at all? Okay, let's watch.
The decision is made. Yep. The die is cast. We're getting out of the coop, and we're going with the cockerel.
Big hopes for this one.
Big hopes.
It's the plush tea cozy in the form of a cockerel's head. This is as cool as you can get. So here we have a cockerel one of the 1930s. Put him on tenner. £10 for it. 10 a bit. 10, 12, 15. Over there at 15. You look like the sort of bloke that would wear one of these. We're up to 32, 35, 38, 40, at 45, 50, at 55, 60, 65, 70, 75, 80, at 85, 90, 100, 110, 120, 140, 160, at 160, 180, at 180, 200, at £200 now.
It's true.
At £200, 220. Are you sure you're finished? No one else coming in the room. 240.
Yes, you've done 240.
At 240. Sell it at 240 then. 250.
Oh,
At
yes.
£250. Anybody else? At 250. It is the most lovely cockerel's head I've ever seen. At 250, I sell then. At £250. No one else in the room.
That is unbelievable. The most...
There you go. So I hope that's perhaps caused some creative associations, some serendipitous creative associations in your mind right now. I hope it's got you thinking about, why people value the things they do. What sort of properties about that object did they actually value? And without further ado, I think we can get into the actual research for today. All right. So essentially what I've done is I've created a concept in my output folder, and it's sort of structured almost like each topic is a paragraph in what will hopefully be like an article or perhaps a video. And so I actually started doing this a while back. Actually, let me see when I started this. This one's been around for a while, maybe. Control-Shift-H. Yeah, a long time. So since I've been writing this for a while now. So the first thing I'm going to do is actually go back and look at what I've done so far. Try and remember about the sorts of ideas I was having, whether they've changed or not, whether I can add anything else in. And then I'll start probably doing some subset reviews, start linking to other concepts, because knowledge valuation is like linked to so many other things, as I was saying in the beginning. So, all right, I'll get right into it. So as I just suggested, in incremental learning, the intervals between when you first see an element and when you next see it can grow to be very large. So often what you need to do is when you next see the element, you need to go back and sort of refresh your memory of what exactly you were thinking last time you saw the element. And actually, I think rather than that being a disadvantage of incremental learning, I actually think it's one of its major strengths, because that time interval in between when you see the elements can act as a filter on some of your misconceptions, and it can also act as sort of a buffer zone where you have a bunch of time to learn the prerequisite knowledge that you weren't familiar with before you next see the topic. And that's especially useful if you're working on quite a difficult problem, or a problem where it requires sort of a deep dive into multiple different areas. If you're interested at all in incremental writing, I definitely recommend that you check out Master How to Learn's blog. He's done a bunch of articles on incremental writing, and as far as I know, most of his articles were written using incremental writing, so he's definitely got a bunch of experience, way more than me, in this domain. Okay, so I've read through most of what I've done so far, just basically loading up my working memory, trying to remember actually what I've done. At this point, what I want to do is show you some of the articles that really inspired this research project. So I think I'll start obviously with the 20 rules knowledge formulation. So essentially, why we made that presentation the other day beyond the 20 rules is because, well, at least for me, a large part of it was that the 20 rules of knowledge formulation only deals with knowledge formulation, or at least primarily deals with knowledge formulation. It doesn't deal with the sort of prerequisite step of knowledge valuation. You need to pick what you're going to formulate before you formulate it, of course. So he does create this meta rule, the pleasure of learning. So one way you can interpret it is that you should be guided towards those topics, those subjects, those pieces of knowledge that are pleasurable for you to learn. However, I don't entirely agree with it. I think that there needs to be some sort of meaningful goal that you're pursuing when you're doing your learning. You need to have some sort of application of the things that you're learning in order to make good decisions about what material you import, what you turn into items, and so on. And this isn't a unique thought. I think maybe I was influenced by this article or working note by Andy, right? And he's basically written that the dominant culture around spaced repetition memory systems is fixated on meaningless goals. And he gives this example, this common failure pattern in my opinion. People often, having found a spaced repetition system, Anki or SuperMemo, they decided to use it to memorize things that really have a very low probability of actually being useful in your real life or anything else. I propose that people need to have some sort of meaningful goal. In terms of valuation, there's this very good article by Was, and he basically tries to disaggregate the value of an item into its component parts. So he basically comes up with this method of deciding whether it's worth creating an item, and it's pretty interesting. I definitely need to reread this. I'm sure I've read this before, but yeah, so I will definitely reread this article in a second. And finally, there's this article, this excellent literature review by Gwen on spaced repetition, and there's this paragraph here where Gwern provides sort of a fast and frugal heuristic for deciding whether it's worth creating an item. And basically it comes down to 5 minutes. He decides that if memorizing an item can save you 5 minutes of time, then it's going to be worth creating that item. And I'm not entirely sure I agree with this heuristic so far. I basically have some preliminary thoughts on that. It basically came down to, the 5-minute rule. It didn't really make sense to me because the distribution of time that you spend on items in your collection is a power law. So 20% of your items require 80% of your time. So those are the leeches in your collection, right? And the rest of them will require very little time. So when you just have one figure, 5 minutes, almost like an average figure, it doesn't really make sense in the context of power law distribution for me. Though I will admit my math is not nearly as sharp as Gwern's, so I could be completely wrong. I just made a task to do a subset review of power law distributions. So hopefully we can find out whether I'm thinking along the right lines. And secondly, I had another thought about, is there a double power law in play? Is item value also distributed according to a power law? And if so, how can we create items that cost us very little time and also provide the maximum value? How can we get items that are like right over here, so they require very little time, and also create the most value, over here, create the most creative associations and ideas. So here I was just sort of fumbling about trying to get that paragraph from the Gwern article back into my collection, since I'd already imported the article at an earlier time. So what I'm going to do, I'm going to leave that paragraph from Gwern under the original article, and I'm going to use links to link it to the output folder, and also a number of other concepts. I'll show you as I do it which ones I think are sort of related to what he's talking about here. So I do link value, right? Value and cost and learning, of course, and what he's talking about here is also related, of course, to the article. So knowledge valuation. Right. Okay. I'm just going to do the rest of those tasks right now that I created for myself. Set. So linking to valuation, linking to Nassim Taleb, who has very interesting ideas about valuation that I'm sure will come in handy. And then I'll do a subset review of whatever I have in my collection about the power law. I might need to go and find some stuff from the internet for this because my math knowledge is very lacking. So, all right, let's link to valuation. Valuation. Here you can see me using the program UELI, which is the keyboard launcher, and I'm using some AHK scripts to help me do some UI automation, setting the concept and things like that. I definitely ought to have a concept for Nassim Taleb because there's so much you can talk about with this guy. So I'm going to go to my people folder and I should turn that into a concept actually. I definitely recommend getting used to AHK if you're going to be using supermemory because it really helps with doing this sort of UI automation thing. So, for example, in order to move around the knowledge tree, I often set the concept and then press Alt-C, and it will basically select right under that concept. So it's really convenient for navigating the tree. And actually what I might do is search in my collection, have I already got a bunch of stuff for Nassim Taleb, and I might move some of it into this concept so it just makes it easier to find. So Control-Shift-P, then Alt-G, Nassim, yeah, there we go. And that will move this under that Nassim Taleb concept. There we go. So in some cases, I've already imported some of Taleb's work under other concepts. So he has the concept of the black swan, right? And so some of his work is already under there. I think what I'll do is I'll link Nassim Taleb to black swan, and in that way, if I do a in that way I can just associate the two concepts rather than moving this under Nassim Taleb in the hierarchy. I can just keep this here and associate them through the links. So. Okay. Okay, yeah, like I was saying, this is very interesting, sort of developing better heuristics for valuing something on the fly. So we've got the 5-minute rule from Gwen. Is there anything that we can add to that? Is there, any other sort of fast rules that you can give yourself to improve the quality of the items you make? And it seems like this would give me a bunch of ideas about that. So I've increased the priority and I'll link it to the output folder. Valuation. So during this period, I was just looking through more of Taleb's articles and just setting the priority or linking to the output folder. This sounds very interesting. Is there a way that we can discuss the uncertainty in the uncertainty inherent in learning something? Like, you can't know before you have a creative association which parts of what you've learned were actually really important for creating that association. It all seems to happen sort of behind the scenes in your mind, unconsciously. So maybe this will be useful. Who knows? I'll link it. Let's see. And increase the priority. Yeah. I think something like this, the normal distribution, that will be important to review so that I can compare it with the power law distribution. One experience I kept having during today's session was uncovering old notes that I'd forgotten actually exist. So that was really nice. It was sort of like uncovering an old journal or something like that. Wow, yeah, I'm finding all of these things in my output folder that I forgot I'd started. Microeconomics of learning. I won't go too much into it, but let's just link it, and we can do, I think, since there's being so many links getting made, I think what I'll do is I'll try a neural review over all of these things and I think that might be the first time I use neural review, so that'll be interesting. So I'll link this as well to the output folder. I'm going to read part of the SuperMemo manual on neural review because I think it does a pretty good job of explaining what it is, but ultimately the best way to sort of understand how it works is to use it yourself. Like, I hadn't used it until today, but now I feel like I have a better understanding of how it works. So SuperMemo 18 features an innovative form of incremental learning, which we will call neural learning. In neural learning, SuperMemo serves the student with knowledge associated with a selected subject, article, picture, or other. Knowledge is served in a neural way by sequentially exploring semantic connections in a network of information built automatically or manually in SuperMemo. SuperMemo takes inspiration from how the brain works. Creativity enhanced with SuperMemo is very slow, but it is targeted and methodical. Neural creativity works like a slow brain extended by memories stored in SuperMemo. Instead of doing the subset review of the power law right now, I want to go straight into a neural review because I've not really done it before, and I think I've made enough links that it should be really interesting and valuable. So I've got to try and, oh yeah, here we go. Go neural. Let's go neural. Okay. So my understanding of what happened there when I clicked Go Neural is that SuperMemo took all of the elements linked either hierarchically or using the link function, which I was using earlier in the video, and created a queue out of them. I think what I'm going to do for this article is actually take the bits that I think sort of summarize what sensitivity analysis is, and I'll try and reframe it in terms of knowledge valuation. Or at least I'll make a topic to do that in the future. I'm not exactly sure whether it will be useful, so I'll just bump down the priority a little bit, 22, and I'll just try and take the bits from this introduction that are written more for a general audience than the math stuff down here. Just highlight the bits that seem particularly interesting to me. This part is interesting. So this is one of the benefits of having like a simple heuristic like the 5-minute rule. When you're reading through your topic and you're deciding what to make items from, you don't have time or brain energy to run something computationally or just cognitively expensive, right? You can't think of every possible situation in which an item could be valuable. So we need to come up with, it seems like we have no choice but to create simple heuristics. This part actually reminds me of Gerd Gigerenzer. He, I think, really stresses the value of the fast and frugal heuristics. So what I'm going to do is extract this, probably give it a high priority because it's really interesting. And then I'll link it to Gerd Gigerenzer, and then I'll link Gerd Gigerenzer probably to the output folder as well. And a good tip is to always write down the associations you had when you made the extract, because otherwise you just tend to forget. It's always good to be reminded of why you found something interesting. So I'll just say, I'll give it a 12. This looks very good. Actually, there are more connections that we can make, like central planning. Central planning. When they talk about this curse of dimensionality, it reminds me of the central planners in, I can't remember which countries. I don't want to get that wrong. I'll check. But they tried to come up with this way to make central planning computationally efficient using linear programming or something like that. And they used a bunch of like dimensionality reduction to try and overcome the curse of dimensionality, which makes it very difficult when you have a large number of interacting variables and interconnected variables to make an optimum decision. So yeah, all of that's going to come in handy. And in fact, central planning is also linked to, for example, having a curriculum. Like in the traditional education system, you have basically a situation very similar to central planning, where people decide which knowledge is worth you learning by packaging it into a curriculum and telling you that you have to learn certain things. And then, of course, there is the sort of self-directed free learning approach, which is sort of models itself more closely after like a free market approach. I don't know if I did a good explanation there, but you can see that it's just so interconnected. Valuation, all of this sensitivity analysis stuff, and computational expense. Yeah, super useful. Yeah, I mean, this looks excellent. What scientific concept would improve everybody's cognitive toolkit? Anti-fragility. Very nice. Convex tinkering. This is another of Taleb's concepts. So what I'll do is I will link this to Taleb. I think I haven't done it already. Then I will import that article on anti-fragility under the convex tinkering one. Why not? Okay. Wow. Okay. Oh, yes. Here we go. Perfectly sets me up for a beautiful item right there. Thank you, Taleb. So around here, I started to realize that pretty much everything Taleb writes is going to be perfect for this project. Oh, man. Learning. Yeah, there we go. Fragile classroom, exactly. Nailed it. This is so cool. The triad. Oh yeah. Oh yes. I'm not really sure what he's talking about with the concavity and convexity. I know I've got that convex tinkering thing. Oh, something about evolution as well. Black swans. There's something mathematical about this. All right. I'm going to take this, extract it. I need to do some more work to try and understand actually what he's talking about with the concave and convex stuff. But this is awesome. This is going to get a 2. Super useful. Like this could be used to like sort of give you a guide on what sort of connections to make, what sort of concepts you could make, and then the connections between them. You know, you could link all of the anti-fragile domains into the same thing, and then all of the fragile domains into the same concept, and find the similarities between them and so on. All right. Right. Are you anti-fragile to such uncertainty, physical or epistemic? Epistemic is what we're interested in, right? I think I can understand what he's saying here. The smaller the probability of some event, the more difficult it is to predict it, the more convex it becomes to computational error. You can't predict it by trying to run simulations or anything. You want to make sure that you have lots of these tiny, you're exposing yourself to events that have very small probabilities of giving you a lot of value, right? Rather than many small events that could completely crumble you, you know? Okay. So that's obviously got a lot of links with finance and stock investments. Yeah, this is amazing. This is getting a 4. I want to see this again and think about it. Changing inequality is the hidden engine history. Now the central point. By simple mathematical property, one can show why under a model of uncertainty. Okay, items in that column. So I'm going to move this under the table. And now I've pretty much got rid of everything, so I'm just going to hit done. Yep. There we go. Back to this one. Let's see if there's anything quickly that we can get. Squaring. Oh, there we go. Squaring is a convex function. Take a die. Consider a payoff equal to the number it lands on. You expect that. Now assume you get the square. Okay, no, I don't understand that. All right. Jensen's inequality I haven't heard of before. For a convex payoff, the expectation of an average will be higher than the average of expectations. All right. I'm going to extract this and keep it as its own thing, as well as having it under here, since it relates to the... Actually, no. I'll just extract this as its own question. Like a 6, yeah. Okay. Let's move on. The reward function and preferences in economics. One of the benefits I found from learning purposefully in order to answer the question and to research about knowledge valuation is that I was thinking about everything in terms of that question. And so when this element came up, I was already primed to sort of think of it in terms of knowledge valuation, and I was trying to make connections effortfully between those two domains. If I were to link this to what I'm doing, knowledge valuation, what I would say is that and I think I've written about this before, but I didn't do a very good job of explaining it. The reward function is like your end goal in learning, right? This is the thing that you try to maximize with some inputs. You try to put a bunch of inputs into your reward function and get the maximum value. And your preferences sort of guide guide you. So your preferences would be sort of like, no, I'm not sure. And another benefit I noticed from doing these sessions and recording them is that I feel more motivated to put in the effort to search for the answer and try and actually connect things together. Yeah, so like I was just saying, I've written about this before. The reward function in reinforcement learning seems to just give me a lot of thoughts about, the end goal in learning. Basically, I'm trying to link it to what I was saying at the beginning, the importance of having a meaningful goal. It's important because it's going to guide the learner's behavior, right? You basically say what you want to accomplish, and then all the actions you take, right, within this system should be consistent with your reward function, your end goal. And in that way, you're always ideally making progress towards that end goal, and learning like meaningful stuff rather than being fixated, as Andy put it, on meaningless goals. That's pretty cool. I didn't know Bing did that. That's actually really nice. So let's say the learner exists in some system or environment. They now have a bunch of, this preferences thing describes when you have like a bunch of different actions that you could take, and you have to select the one that will, to link it to the reward function, maximally satisfy this reward function and give you the most reward possible. How to link that to learning? In learning, I suppose a very simple example, you click on a topic and you see some interesting paragraph. It's interesting because you think it might give you progress to your to fulfilling your reward function and reaching your end goal in learning. So now you have a choice of two actions. You can decide whether to make the item or to just not make the item. And you do like a cost-benefit analysis. Is it worth making this item? Will it bring me closer towards my goal? Right? That's pretty good. I think I squeezed as much as I possibly could out of that, because I don't really know a whole lot about machine learning, reinforcement learning, reward functions, or preferences in economics, but that seems to be pretty cool. I like the idea of visualizing, like having like an x1, x2 down to xn, and then having to order them, decide which one has the most value, and then play that action into the system, observe it. Did you get a reward or not? Nice. One thing that would be good to add to neural review would be some setting to change how related you want the elements in the queue to be related to the original element that you started the review on, because I found that a lot of the elements I was being shown were quite unrelated to actually what I wanted to do. But I suppose perhaps you could just simply use a subset review if you were more interested in having something very closely related to the question at hand. Here we go. Understanding is a poor substitute for convexity. This looks like a Taleb one. Right, perfect. Yes. Oh yes, I can see a metaphor or analogy here, so I know it's going to be good. Where is this in the tree? Convex tinkering. Okay, okay. So what I'm going to do right now is just take a quick break, and then I will get straight back into it and start extracting all the useful nuggets from this paper by Taleb. All right, guys, so I'm back after a little break, and I'm going to get stuck into this paper here. I think perhaps I actually finished the paper and maybe I'd copied all of this stuff that I found interesting from the paper into this topic, but I'm going to make sure that there's nothing still in that paper that's interesting. So I've got to find it on the internet and take a look. Very good. Okay, straight away. Logically, neither trial and error nor chance and serendipity can be behind the gains in technology and empirical science attributed to them. By definition, chance cannot lead to long-term gains. It would no longer be chance. Trial and error cannot be unconditionally effective. Errors cause planes to crash. Knowledge to regress. Okay. This should be much higher priority. 9. 9. But that's sort of what I've concluded from this paragraph. It's not clear to me exactly what he's saying yet. So it seems like what he's saying, rather than trial and error or chance, pure chance, what you have is this, some sort of asymmetry between the potential payoff, the potential gain, and the cost. And this definitely links to items for me. Like, items, when you review them in a space repetition system, the cost is very low because it's been optimized to show you things at the perfect interval and minimize the cost of retaining knowledge over time. But of course, the potential payoff from an item could be very large. You could have a huge gain from making some creative association that allows you to solve some problem, start a business, whatever. I think that's why I became interested in this idea from Taleb. So I'm going to include this picture and try and make sure that I actually understand what he's saying here. I'm especially skeptical of this part, that I don't think I got fully what he was saying. This really showed the value of redundancy in terms of articles and having multiple articles that explain the same thing, because I struggled for a while to find a good explanation of convexity, and then finally in this little paragraph it really made sense in my head. Finally, a good explanation of convexity here makes it very clear, or at least it should do. I'll get back to this extract in a sec. Optionality, yes. Very good. Very good. This is a great article. This is really good. This is clearing up a lot of misunderstandings that I had about Taleb and his work, and those concepts of convexity and concavity. And it's giving me a bunch of ideas for knowledge valuation as well. Gain from the disorder cluster. Wow. My goodness. Okay. Oh yeah, I want to reframe that in terms of learning. Reframe. Learning. Yes. 7 rules. Here we go. These can be part of our heuristics for knowledge valuation. We could have 7 rules of anti-fragility for learning, in learning, right? Reframe in terms of learning. You know, is there anything here that can give us a better understanding of the sorts of items we should be making that could be, you know, more nuanced than the 5-minute rule that Gwern suggested, right? This is a 1. This is just excellent. And I'm going to link it directly with the output folder. Knowledge valuation. And it's already in complex tinkering, so that's fine. Okay. Yeah, that's a really good one. Damn. Okay. Yeah, I really think I understand what he's saying now. So yeah, I'm going to stay in this branch for a little bit and just go back and forth, trying to, you know, restate things in my own terms. Try and do the reframing thing, reframing what Taleb is saying in terms of learning, and yeah, let's do it. This is a reminder to always bring snacks to a long incremental reading session. Damn, I'm getting super hungry. All right. Yeah, guys, I'm going to take another break. I'm just getting so hungry, but I'm excited to get back into this because this article is, you know, it's just full of golden nuggets. So I'll see you again in maybe 10 or 15 minutes. All right, guys, I'm back after getting some food. Let's get back into it. Rejuvenated after getting some food, I got straight back into the article and started making some items, especially from things like convexity, since that was one of the things that I had actually originally really struggled to understand, and this article really cleared up for me. So this is a pretty critical portion of the article for me. Critically, convex payoffs benefit from uncertainty and disorder. The nonlinear properties of the payoff function, that is, convexity, the asymmetry between gains and losses, allow us to formulate rational and rigorous research policies, and ones that allow the harvesting of randomness. This is just fantastic, this section. It really links to my whole idea about you know, adding purpose and goals and meaningful goals to the 20 rules. You know, having a goal and then learning towards that goal, and trying somehow to find ways to do that, exploiting the this convex payoff property somehow. Yeah, so you can have a teleological research agenda that still exploits this property of convexity. I think that's what he's saying. It's like, so you can have a framework, you can pursue technological or scientific advances systematically. You just need to make sure that you're searching for these convex payoffs. Okay, that's good. Very, very good. 3. And I'll turn those things into items. Not so sure about this one, so I will just leave it, and next time it comes up I can decide whether I want to make that or not. And this I'm going to link directly with the output folder, since it's so critical, I think, to understanding this and generating more ideas about knowledge valuation. I think in learning, the X, your input into your learning is time, I think. I've felt like that for a while, because so much of information now is free online. Yeah, understanding the payoff function, having a goal in learning, I think, is important to understand the payoff function. So let's take a very simple example. Let's say that your payoff function, your goal in learning, is to make as much money as possible. Then for each unit of time you input into your learning, you want to make as much money as possible from each unit of time that you input. And you want to exploit convexity. If you input time and things don't go as planned, you don't want to lose. I don't know if that makes sense, but I'm not sure if I can make the payoff function like how much money you get, because I think the X measured in time and f of x measured in money. I don't know if that makes sense. I don't know. I'll leave a note. Think about it. Perfect, yeah, there you go. Live just formulating it for me. Don't even have to do any work. Beautiful. There you go, nice cooking analogy to make it intuitive. Beautiful. Heuristics of trial and error. I think I'm going to move on to the next thing at this point. This article is excellent. So much useful stuff in there. Yeah. I'll link that directly with the output folder because it's so fundamental. Okay, it's already there. Let's go. Whenever I say it's Douglas Hofstadter, I know it's going to be something good. And this, of course, is no exception to the rule. The parallel terrace scan. So the idea of the parallel terrace scan, I think, is that you explore many different possibilities concurrently, and for each possibility, you estimate the expected reward and invest resources in that possibility according to its expected reward. And it basically just reminded me a lot of the process of incremental reading, right? You import topics and you set their priority, and because your queue is sorted by the priority, you will over time, invest more resources in those that have a higher priority than those that have a lower priority. And of course, you are studying many things in parallel. So in my mind, the process of incremental reading, or just incremental learning in general, this applies to the incremental approach, no matter what material you're studying or how you're studying it. You know, you're exploring in parallel and investing resources in a way that attempts to be optimal. At this point, I was getting pretty tired, so I ended up not really being able to make any more connections. I don't know. I know it's connected in some way, but I just can't think. I think I'm getting a little bit tired. I'll decrease. I'll increase the priority a lot. I want to see this again. I think it's such a good idea. I know there's a couple of people in the Discord who I'm going to send this to who are going to really like this idea. I'll make a note of that, send it to them. Yeah, this could be related to knowledge valuation, maybe perhaps you could frame learning as trying to minimize your regret from not picking the best thing to learn. You try your best to pick the things. You try and pick things to learn that will give you the most benefit, and you try and minimize the regret from not picking the best thing to learn, if that makes sense. Yeah. How do we avoid regret in learning? There we go. Regret aversion. That sounds really interesting. Yeah, this is good. This is more tangentially related, I think, but it's still pretty good. I'll definitely link this directly to the output folder. And I think I'll move on. Okay, I think at this point, I'm going to go back to the output folder and see if I can just write up any of the ideas I've had so far. Yeah, I think the research part was really productive. I managed to find a bunch of ideas, especially from Taleb. He was pretty instrumental in this session today. I would have liked to get more writing done, but I can just feel myself getting tighter and tighter. So I don't know. I'll see what I can get done in terms of writing, and if I'm not able to get anything done, that's fine. I've already had a pretty good day so far, so let's see. Output. Valuation. All right, I think that's pretty much summarized all of that reading that I did. So that was really interesting. That's pretty much the first time I think I've used neural review, and all of those links that I made between all of the different concepts like Nassim Taleb and all of the power law, normal distribution stuff, and all of the other things I read today. That's really going to come in handy in the future when I come back to this topic and I want to make more progress. I can just go back to this concept, go back to learn, neural review, and it will go back all through all of those concepts and items that I link between, which will provide a lot of like, hopefully some creative serendipity and new associations and things like that. So I think that's it for me today. It was a really good session again. If you enjoyed this video, do let me know, and I'll see you in the next one.